When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
Halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant cut.
Hi dears, this is our 12th day of MCQ challenge. I hope you guys are doing well. So today we are going to discuss about the chapter solution. You know, it's a physical chemistry related topic. Actually these are somewhat complex, but I hope while we are solving this one, while we are reading this one, while we are reading the topics very carefully, this one will be easy, a smoother one. Okay, shall we start the questions? Ready? Are you ready guys? Okay, so this is the first question guys. This is the first question. What's the first question? Here there's a assertion is given as well as one reason is given. While we are looking the assertion, what's the assertion? In an ideal solution, delta H mix is 0. We know that. What is ideal solution? In an ideal solution, delta H mix is 0. Of course, in the case of an ideal solution, there is no enthalpy is releasing, no enthalpy is absorbing. So delta H mix is obviously it will be what? It will be 0. That is 100% correct. Correct now? Yes or no? So assertion is true only. Delta H mix is 0, as well as we know delta V mix also 0. Delta V mix also 0. There is no volume change. Okay, while we are mixing a 90 ml solution A with a 10 ml solution B, net will be 100 we will get. There is no increase in volume, there is no decrease in volume. So delta V mix equal to 0, delta H mix equal to 0. That is correct. Why it's so? Why it is happening? Because we know that the interaction between solvent molecule, that I am writing FAA, as well as the interaction between solute molecule, that I am representing FBB, as well as the interaction between solvent and solute, that is FAB. This all are equal. This is the idea you are learning about ideal solution. Especially along with that, you must have to remember what also? They should obey Raoult's law also. They should obey which law also? Raoult's law also. So these are the important concepts regarding ideal solution. Now we can check the options. Assertion, in an ideal solution, delta H mix is 0. That is correct. That is correct. There is no change in enthalpy. And the reason, what's the reason? In an ideal solution, AB interactions are lower than AA and BB interaction. That is wrong. Why? Because we already write in the case of ideal solution, the interaction between solvent as well as solute as well as solvent and solute will be same. So automatically the reason also what? Reason also true, reason also wrong only. So assertion is true and reason is wrong. So which one will be the correct answer? Assertion is true and reason is false. Option C is the correct answer. How many of you got it guys? Tell me. Yeah, Faraz is telling the answer and Fahad Ali is also telling the answer already there. They already gave the answer. Okay, yeah. Love and fire is coming. Yes, great. Okay, listen. So next, shall we go to the next question? Guys? So this is the next question. Listen to me very carefully. Assertion. They given one assertion. Osmosis does not take place in two isotonic solutions separated by semi-permeable membrane. And they given the reason. What's the reason they given? Isotonic solutions have same osmotic pressure. Okay, same osmotic pressure. We know the idea. Already answer is coming. Already answer is coming. Okay, so we know the assertion. What about assertion? Osmosis does not take place in two isotonic solutions. So we are taking two isotonic solution. What is isotonic solution? Both of them have same concentration, or both of them have same osmotic pressure. Here also osmotic pressure we are representing pi. Here pi 1. Here also pi 1. Both are pi 1 and they are separated by semi-permeable membrane. Then there is no osmosis. Both of their osmotic pressure is same, means there is no osmosis. Okay, so isotonic solution separated by semi-permeable membrane, there is no osmosis. Okay, so that idea is correct. That assertion is correct. Okay, ready? And what about reason? Isotonic solutions have same osmotic pressure. That's why only there is no movement of what? There is no movement of solvent. That reason is the perfect answer for the assertion. So that's why which option we will take? Both assertion and reason are true, and reason is the correct explanation of what? Assertion. So which option is correct? Option A is correct. I hope you are answering already for us. Yeah. Karthik is answering, Fahad is answering, yes. Aditya is giving some fire. Okay, great to see that. Okay, nice. Shall we go to the next question, guys? Ready? Yeah. Okay, ready. So this is the next question. What about the next question? You can see the assertion. What about assertion? Lowering of vapor pressure is not depend on the number of species present in the solution. I am keep on asking this kind of assertion and reason because I know that you people are always making errors in assertion and reason. That's why only I am keep on asking this kind of question. Okay, listen the question, read the question very carefully. Ready? So here, lowering of vapor pressure is not depend on the number of species present in the solution. Is it correct? That is wrong, because they are telling not depend on the number of species. Obviously, lowering of pressure depends. What do you mean by lowering of pressure? If you are taking a solvent, to that you are adding some solute, its vapor pressure will be decreases. If you are adding more solute, its vapor pressure will be more decreases. So that statement is wrong. They are telling lowering of vapor pressure is not depend on the number of species present in the solution. That is wrong. And what about the second one? Reason. Lowering of vapor pressure and relative lowering of vapor pressure are colligative properties. Which all are the colligative properties you learned? First one, relative lowering of vapor pressure. Ready? RLVP. What about the second one? Second one is elevation in boiling point. Ready? And what about the third one? Third one, depression in freezing point. Okay, freezing point. And what about the fourth one? Osmotic pressure. Okay, osmotic pressure. These are the colligative properties. Is it lowering of vapor pressure is colligative property? No, we know that is not. Okay, so this one they are telling in reason lowering of vapor pressure and relative lowering of vapor pressure are colligative property. That is wrong. Only relative lowering of vapor pressure is a colligative property, not lowering of vapor pressure is not. So that's why this is also wrong. So both are wrong. Assertion is wrong, reason is wrong. What will be the answer? Both assertion and reason are false. Option D is the correct answer. I hope already Sanjay Menon is already answering, as well as Faraz, okay. And NDS Sahil is telling, yeah, great to see that, okay. While I am looking the comment box, I am feeling like somewhat more happiness because so many are sending loves as well as hearts, as well as flames are coming, as well as the fire is coming. Okay, great to see that. Okay, so I hope we can go to the next question again. Guys, I hope you are ready. This is the next question. Sanjay, I hope you are listening. This is the fourth question. Assertion. They are giving one assertion. Read the assertion very carefully. What's assertion? 1 molar solution of KCl, okay, has greater osmotic pressure than 1 molar solution of glucose at the same temperature. Is it correct? Yes or no? Yes, we know what? We know the osmotic pressure formula, pi equal to, what's the formula of pi? Pi equal to I into, don't forget I. Okay, don't forget I, one dot factor, I into CRT. This is the formula, pi equal to I into CRT. Here they are telling same temperature. So we can take temperature is what? Temperature is a constant. Temperature is a constant, as well as R also a constant. And they are telling 1 molar solution of glucose as well as 1 molar solution of KCl. So meaning CRT is a constant. C also, concentration also constant. So C is constant, R is constant, and T is constant. Meaning what? Pi directly proportional to what? I only. Whenever I increases, pi also increases. Whenever I increases, pi also increases. So what about the I for KCl? I for KCl is 2. Why? What is I? In the case of ionic compound, number of ions. So in the case of KCl, it will dissociate like K plus and Cl minus. So 2 ions you are getting. So I value is equal to 2. What about the case of glucose? Glucose, sucrose, fructose, etc. Mainly the organic compound except carboxylic acid. In the case of carboxylic acid, there may be a chance of association. Okay. So here it is I value is 1. In the case of glucose, it is 1. Now we can check whether the assertion is correct or not. 1 molar solution of KCl has greater osmotic pressure. Correct only, because its I value is greater. Whenever I value increases, pi increases than that of 1 molar solution of glucose. Yes, correct, because in the case of glucose, I value is how much? 1. I value is 1. So assertion is correct. What's the reason? In solution, KCl dissociate to produce more number of particles. That's correct. Here KCl is producing 2 particles. In the case of glucose, there is no association, there is no dissociation, so I value equal to 1. So that is the correct, exact explanation. So what's the answer? What will be the answer? Option? Which will be the answer? Option A will be coming. Both the assertion and reason are true, and the reason is the correct explanation of what? Assertion. Option A is the correct answer. I hope you guys are doing well. Correct? Ready? Okay. So if it's so, then we can move to the next question. Question number 5. This is the question number 5. What's the question? Here again I am giving one assertion, one reason. Okay, you have to go through the assertion as well as reason very clearly, very carefully. Okay, everywhere there is some kind of twist will be there. Don't forget that. Okay, so here what's the assertion? What's the assertion they given? 2 liquids, nitric acid and water. Nitric acid and water. Even though in competitive exam also they usually used to ask this one, HNO3 plus water, HNO3 plus water, acid plus water. Okay, they can form intermolecular hydrogen bonding. That idea you have to keep. Okay, form maximum boiling azeotrope. Yes, they can form intermolecular hydrogen bonding means there is a interaction between solvent and solute is more. Solvent and solute is more. Automatically they will show negative deviation from the ideal behavior, from the Rolle's law. Negative deviation means their boiling point will be more than that of either of the two. That means maximum boiling azeotrope when mixed in the ratio 68% to 32%. Okay, by volume. That is correct. That statement is correct. What is the reason behind that? Why their boiling point is increasing? Once you are mixing HNO3 and H2O, there will be a intermolecular hydrogen bonding formed. So that means the solute solvent interaction is more. Automatically the boiling point will increase. So interaction between nitric acid and water are stronger than nitric acid. Okay, nitric acid alone means interaction is less. Water alone means interaction is less. But when nitric acid comes together with the water means there is a interaction is more. Automatically boiling point will increase. It is the correct explanation. So the reason also correct only, correct explanation also. So what's the answer? Option A is coming. Both assertion and reason are true, and reason is the correct explanation of assertion. How many of you did it correctly? Okay, tell me in the comment box. Ready? I am ready to look. Okay, ready. Comment box, please. Yes. Fire is coming. Yes. Answers are coming. Okay, ready. So we can go to the next question. I hope we can go to the next question. Yeah, everyone are telling the answers. NDS Style is telling the answer. Pinky Mole is telling the answer. And Faraz is telling the answer. Yeah. Thank you so much for all your love. Okay. Yes, thank you. Then we can go to the next question, guys. We can go to the next question. This is the question. Okay, guys. I hope you are watching with that much energy. Okay, ready now. So, which of the following units is useful for relating concentration of solution with a vapor pressure? It is a simple and humble question. Vapor pressure is connecting with which one? That's only Raoult's law. What? Vapor pressure is directly proportional to what? Mole fraction. So, what's the answer? Mole fraction. Is it so? How many of you got the answer? Yeah, Pinky Mole. Yeah, Sanjay Menon. Yes, great to see that. Okay, everyone are seeing. So this kind of question also will come. That time some of you may be thinking like, is it parts per million? Is it mass percentage? Is it molality? No. If you are looking parts per million means that you have to remember that's a speciality for parts per million. That also you have to remember. Parts per million mainly we are using for the whenever our solute content is very less, minute. That time only we will use what? Parts per million. Okay, that idea you have to keep it in mind while you are watching this video. You have to note down there what? Parts per million is used in the case of what? If your solute is very less in amount compared to the solvent, in a large amount of solvent, very less solute is there, we are using what? Parts per million. Out of 10 raised to 6, how much amount of solute is present? That only parts per million. I hope you guys are following. Ready? Okay, then we can go to the next one. We can go to the next question. I hope, Karthik is telling the answer. Fasil is telling the answer. Fasil, keep the spirit. Okay, ready? This is the next question. What about this question? This question answer and all we know easily, but we are looking at the chemistry behind it. Okay, so on dissolving sugar in water at room temperature, solution feels cool to touch. While you are adding sugar in water, solution feels some coolness. What's the meaning? Endothermic reaction, nothing much. If it is hot means what's the meaning? Exothermic reaction. So meaning we can write the equation like what? Sugar is a solid while I am adding to water. Water is a liquid to water is a liquid, and they will form what? A reversible reaction. We can write reversible like that. We can write, okay. If it is a saturated condition means reversible, okay, or else it is a one directional reaction. Okay, no problem. So here I am getting sugar solution I am getting. Okay, sugar solution I am getting. So the idea is sugar solution is aqueous. The idea is what they are telling, it feels to cool to touch. What's the meaning? This reaction is what? This reaction is endothermic. So I can write delta H solution is positive. That is endothermic. That during that solution formation, some heat energy is absorbing. That's why only that coolness. Okay, ready? So that means the forward reaction is endothermic. Backward reaction is exothermic. That's it. If forward is endo, backward is obviously what? Exo. That's it, nothing more. Then, what's the question? What's the thing they are telling? Under which of the following cases dissolution of sugar will be most rapid? What do you mean by dissolution? That sugar plus water that dissolve to give sugar solution, that's only called what? That's only called a dissolution. This reaction is called a dissolution. That means forward reaction is called a dissolution. When dissolution will occur? Whenever endothermic is occur, that time dissolution will occur. When endothermic will occur, that we learned according to by using Le-Chatelier principle, we know that when temperature increases, more dissolution, more endothermic, or else if you don't know about Le-Chatelier principle also we can answer it, because if you are taking water and if you are adding some sugar and at a particular point that water can hold maximum amount of sugar, that point is called saturation. And then if you want to add more means what you want to do? You have to heat it. You have to increase the temperature. That time again sugar we can add, then it will attain another point that is called super saturated. Okay, you know the idea here. So if we want to add more sugar means what we have to do? We have to use hot water. We have to use the temperature should be more hot water, and if the reaction should occur in most faster rate means its surface area should be more, so we have to use powdered sugar. So what's the answer? powdered sugar in hot water if you take means this dissolution process will be more. This idea, if anyone have common sense means you can answer it. Very simply you can answer it. Already answer is came here. Yeah, Naveen Badda Marapalli. Yeah, great to see that. Okay, Navina, thank you so much. Okay, so I hope you can answer it. Yeah, Karthik telling answer D, and Sanjay Menon is also telling the answer. Yeah, correct only. Powdered sugar in hot water. Okay, correct only. Ready. Shall we go to the next question? I hope you guys are really watching the video. Correct now? Yeah. Great. Okay. So here, this is the next question, guys. This is the next question. What about this question? This is the 8th question. What's the question? At equilibrium, the rate of dissolution of a solid solute in a volatile liquid solvent is. This one only we did it in the previous question. What's the idea? We are having a solid solute. Okay, a solid solute is there. That I am going to put in what? A solvent. That solvent is what? Volatile liquid only. Then I am getting what? A solution. I am getting a solution, and solution will again crystallizes into solid and solvent. Okay, and the forward reaction is called what? Forward reaction is called dissolution. This is called dissolution, and the reverse reaction is called what? Crystallization. So it is actually a type of physical equilibrium only. It's actually a type of physical equilibrium only. So here what's the condition they are asking? At equilibrium, the rate of dissolution of solid. The rate of dissolution of solid will be equal to rate of crystallization. Rate of forward reaction will be equal to rate of backward reaction. Then what will be the answer, guys? What will be the answer? Yeah, flip-flop is telling the answer. Faraz is telling the answer. Yeah. Great. For us, we will give it. Okay, don't worry. We will give it. I will give it. Okay, don't worry. So equal to the rate of crystallization. So option C is the correct answer. Option C is the correct answer. Yeah. Everyone are telling the answers. While I am seeing the answers in the comment box, I am feeling like very much happy because you know that. You guys know it. Okay, that's it. Because these all are simple questions only, but you usually used to make the mistakes. That's why only we are keeping this question again. Okay. Yeah. C is coming. Yeah. NDS is telling the answer. Yes, great to see that. NDS style. Okay, then again we are taking the next question. We are going to the next question. That is the 9th question. What about the 9th question? A beaker contain a solution of substance A. Okay, substance A. You are containing a solution of substance A. Solution of substance A is there. Okay, with you. And precipitation of substance A takes place when small amount of A is added to the solution. Again, you are adding small amount A. That time precipitation takes place. The solution is. You must have to remember, first of all, if you are having one solvent is there, to that if you are adding a solute, that solvent can hold a maximum of solute. That point is called saturation. So up to saturation, you can add solute again. Then again saturated state, if you want to add solute again means you have to heat it. That time you can add again and then reaching the super saturated state. And after super saturation also, if you add some small amount of solute means what will happen? They will precipitate. So option, which one is the correct answer? Super saturated. The solution should be super saturated. That time only what will happen? They will precipitate. I hope you guys got it correct. Yeah, Sanjay Menon, option B is the correct answer. Yes, Faraz is also telling answer. Sanjay Menon's NDS style is telling. Yeah, great to see that. Okay, so that is super saturated. Okay, not unsaturated, not saturated. Okay, ready? Shall we go to the next question? Yeah. This is the next question, guys. What about this question? Maximum amount of solid solute that can be dissolved in a specific amount of a given liquid solvent does not depend upon. Again, I am putting the question from this area since because of that you may be familiar with the colligative property, you may be familiar with the ideal solution, you may not be familiar with the initial some introductions are there in NCERT. From there also they can ask the questions. Okay, that's why only I am keep on asking this question. Okay, don't feel like that why sir is asking this kind of question. Don't feel like that. That's the reason behind it. Okay, ready? So this is the question. Maximum amount of solid solute that can be dissolved in a specified amount of a given liquid solvent does not depend on. We are having a solid solute that I am adding into adding into specific amount of given liquid. Into a liquid I am adding, then they are forming what? A solution. They are forming a solution. Now they are asking, we have to add maximum amount of solid solute into that one, which is does not depends on which quantity. This dissolution process does not depends on which quantity. Temperature, of course, temperature is depending, because whenever temperature is increasing, we can add more solute. Okay, and what about nature of solute? That also correct. If you are taking ionic solute, if you are taking ionic solute in ionic solvent, the dissolution process is more faster. Ionization is easy. But if you are taking covalent, means that ionization and as well as the dissolution process will be lesser, smaller, not that much rate. Ready? So nature of solute is important, nature of solvent also important. Nature of solute is important, nature of solvent also important. What about pressure? Pressure is not for liquid and solid, it is for what? Gas. It is for what? Gas. Don't forget the idea. This idea you need in where also in chemical kinetics also you need the idea, as well as in electrochemistry also you need the idea. Pressure is for what? That's for gaseous molecules only, not for solid liquid. Okay, so that's the idea. So what's the answer? Does not depends on. The answer is pressure. Yeah, I can see the answer. Muhammad Isham is telling the answer. Yeah, Sanjay Menon. Hi Isham. Hi Sanjay Menon. Yeah. Answer is coming. Yeah. Great to see the answers. Okay, and you have to keep some fires also there, then only I will also become more energetic. Okay, yes. Shall we go to the next question? Yeah, this is the next question, guys. This is the next question. What's the question? Low concentration of oxygen in the blood and tissues of people living at a high altitude. So while we are going to the Everest, Mount Everest, or else in Kashmir, or else in Ladakh and all, that is a high altitude region. While we are going there, the oxygen deficiency will come. That means anoxia will come. Oxygen deficiency is called anoxia while we are going to the that so many passes are there in Kargil and all. Okay, so you if you get a chance to go there, means you have to go there. Okay, it's a awesome places only, Kashmir and all. After your exam you have to go there. Okay, so anyhow, once you are going there, means there the oxygen in blood will be decreases. The dissolving power of oxygen in blood will be decreased because the pressure is decreases. Atmospheric pressure is low. That's why when pressure is low, means solubility also will be low. So that's why what will happen? Pressure is low outside, means what will happen? There is a possibility of our inside pressure, body pressure will be more, means that time there's a possibility of blood will come out through your nose and all. That's a possibility there. Okay, and anoxia, if oxygen is absent, means if there is a large amount of oxygen is absent, means there's a cause of death also. That's why only whenever we people are going to that much hilly area and all, we usually used to keep oxygen cylinders or else some tablets also. Okay, so anyhow, you have to remember this idea. Don't forget the idea. Living high altitude, what will happen? Living high altitude, low atmospheric pressure is the answer. So pressure is low means solubility also low. That is Henry's law. You know, when pressure is high means solubility also high. That idea we know now. In soft drinks and all, we are applying more pressure, means more carbon dioxide we can enter into, we can dissolve in that particular water. Okay, I hope you guys know it. Okay, similarly, if I am going to the mines, I mean underground, okay, in earth, if I am going downside, what will happen? There the pressure will be very high. Okay, than the atmospheric pressure. There solubility will be more. So there is some another problem will be happening there that you will learn in further classes. Okay, in higher classes, in medical classes and all, you will learn it. Okay, don't worry about it. So anyhow, this is the concept, this is the idea. I hope you guys got it. So low atmospheric pressure is the answer. I hope you guys got it. Yeah, for us, Muhammad Isham. Yeah, low atmospheric pressure. Yes, great to see the answers. Okay, ready? Then if it's so, then we can go to the next question, guys. This is the next question. What's the question? This is a question related to, I hope you love this question because you already learned the ideas. Okay, so what's the question? Considering the formation, breaking and strength of hydrogen bond. Okay, breaking and strength of hydrogen bond, predict which of the following mixtures will show a positive deviation from Raoult's law. So whenever Raoult's law, if they are showing a positive deviation, means there should be a breaking of hydrogen bond, intermolecular hydrogen bond, then only positive deviation. So that means solute is there, solvent is there. If you are trying to mix them, they are breaking the intermolecular hydrogen bonding, means they won't come closer. That's why only maximum what? Maximum deviation, that is positive deviation. Positive deviation, that's why minimum boiling point will be there. So in which case they are asking? We know we can take the option nitric acid and water. That I already told you. That is what? That is negative deviation showing solution, because nitric acid and water, if you mix, means they will form intermolecular hydrogen bond. What they will form? Intermolecular hydrogen bond they will form. So that's why that is negative deviation. That is not the answer. What about chloroform and acetone? This is also negative deviation only. What about phenol and aniline? Phenol and aniline can form some kind of intermolecular hydrogen bond they can form. So, and also that's a kind of ideal solution only, not negative. They are ideal solution only they are. Okay, some kind of ideal solution only they are. So what's the answer? Methanol and acetone is the correct answer. What's the correct answer? Methanol. In methanol there is a intermolecular hydrogen bonding is there. While you are mixing it with acetone, they won't come much closer. That's why there is a maximum deviation. There is a positive deviation from the Raoult's law. So option A is the correct answer. How many of you got the answer? Yeah, methanol and acetone. Yes, Muhammad Isham. Yeah, great to see that. Pinky Mole. Yes. Okay, Muhammad Isham, Titan submersible. Yeah, some Titan submersible. That only the idea while we are going downside. That I already told. Okay, anyhow we can discuss that thing in later. Okay, this idea is okay. Ready? If it's so, then we can go to the next question, guys. This is the next question. What about question number 13? Question number 13. Okay, so colligative properties depends on. I hope you heard about colligative properties. So what is colligative property? Colligative properties are the property which depends only on the number of solute particles. What? Number of solute particles, not nature of solute particle. I hope you learned already. Yeah, Gujman is here. Okay, Gujman. Hi, Gujman. Okay, I can see there. Okay. Happy to see you. So here, that depends on what? Colligative properties depends on what? The number of solute particles in solution. That's the answer. Not the nature of solute particle. Not about the nature of solute particle. That depends only on the number. Only on the number. That means only the quantity, not quality. But while I am seeing the comment box and all, I am feeling like that quality is important than quantity. Okay, numbers are less, but quality is very high. Everyone is telling answer. Yeah, fire. Okay, great to see that. But here, in the case of colligative property, what's the condition? Quantity should be more. Not about the quality. Whatever the solute, they are not be bothering, but the number of solute should be more. That's the answer. Okay, so what's the answer? The number of solute particles in solution only depends on colligative property. Option B is the correct answer. Ready now? Yes, Sanjay Menon. Yes, B is the correct answer. Okay, correct. Okay, so then we can go to the next question. This is the next question, guys. This is the next question. This is somewhat a mathematical related question. Okay, anyhow you can answer it. Which of the following aqueous solution should have the highest boiling point? Out of this, which one of the following will have the highest boiling point? That's the question they are asking. So we know what's the formula for elevation in boiling point. Delta TB equal to I into KB into molality. Yeah, answer is already coming. Okay, answer is coming. Yeah, Sanjay Menon, correct only. Ready. Super. Nice. Okay, nice to see your answer. And yeah, G also telling KB into M. So here we are taking aqueous solution. Automatically solvent is same. KB is constant. And the concentration also 1 molar. So that means molality and molarity. Concentration, that idea is enough. What about delta TB then? Delta TB is directly proportional to I. So whenever I increases, delta TB increases. That means elevation in boiling point increases. Now we have to look about the I value. What is I? Van Hoff factor value. What about the Van Hoff factor value for NaOH? In the case of NaOH, it will dissociate as Na plus and OH minus. Then what is I value, guys? Tell me. Come on. Yes, I value is how much? I value equal to 2. What about the case of Na2SO4? Na2SO4 will dissociate as, I hope you know that Na2SO4 will dissociate as 2Na plus SO4 2 minus 2Na plus SO4 2 minus. Then what is the I value? Here how many ions are there? 2Na plus 1 SO4 2 minus. That means total 3. Total 3 is the answer. I equal to 3. What about NH4 NO3? Ammonium nitrate. Ammonium nitrate will dissociate as ammonium ion plus NO3 minus ion. So what's I value? I value equal to 2. I value equal to 2. What about KNO3? K plus plus NO3 minus. So that means I value equal to how much? I value equal to 2. So in which case I value is maximum? In the case of Na2SO4 only, I value is maximum. What's the meaning? So their elevation in boiling point is more. That means their boiling point is more. So what's the answer? B is the correct answer. B is the correct answer. I hope you guys got it. Yeah, Pinky Mole. Yeah, correct answer only. Ready for us. Yes, Sanjay Menon, that's the correct answer only. Suppose, if they are asking, suppose instead of this one, if they are asking the question like this, like what? Which one of the following will have minimum freezing point? Listen my question very carefully. Which one of the following will have minimum freezing point? Which one will be the answer? Tell me. I'm ready to look your comment box. Okay. If they are asking the question like that, which one will be having minimum freezing point? Which one will be the answer then? Okay, for us. Yeah. Sanjay Man is telling. Yeah, answer is telling. Yeah, G is telling the answer. Yes. For us, correct only. Reason is correct only. Yeah, you understand. The idea is simple. Saying, if we are looking about the freezing point, means what's the concept we have? Delta TF. What about delta TF? Depression in freezing point colligative property. That we can write I into KF into M. I into KF into M. Here KF and M are same. So delta TF again directly proportional to I. So in which case the minimum freezing point is deviated from the zero value. In maximum cases, which case? In the case of I value is more, means that will be having minimum freezing point. So answer is again what? This B only will come. I hope you guys got it. Yeah. Great. Okay. Yes. Nice to see the answers. Okay. So if it's so, then we can go to the next question. That is the 15th question, guys. This is the 15th question. What about 15th question? They are asking you to find out the unit of ebullioscopic constant. What is ebullioscopic constant? Kb. Ebullioscopic constant Kb, or else it is called molar elevation constant. Kb is also called what? Molar elevation constant. Molar elevation constant. This is another name. Okay. They are asking you to find out the unit. What's a unit? They given 4 units are there. I am expecting the answers, please. Yes. Sanjay Man has already told the answer. What about others? Yeah, for us. Gujuman. Mohammad Isham. Yes, Sanjay Menon. Yeah, correct only. What about others? For us. Yeah, answer is coming. I hope so. Answer is coming. Yeah. Great to see that. Ramanujan, I hope I cannot see you properly. Yeah. Answer is coming. Okay. So Kb equal to Kb, molar elevation constant. They are asking about what? Its unit. How we can solve it? Very simple. We know the idea. What's the idea? We know delta TB. We know delta TB equal to, what's the formula? Kb into M. Because I, sir, in the previous question you use I. Why you are not using I? I having no unit. That's why only I am not taking I. Okay. I means what? Abnormal divided by normal. Likewise you are taking now. So that time there is no unit for I. So that's why I am not taking it. I am simply writing Kb into M. So they are asking about the unit of Kb. So what is the unit of Kb? Kb equal to delta TB by M. What is delta TB? Elevation in boiling point. What's the unit of elevation in boiling point? Kelvin. Boiling point means Kelvin divided by molality. So that molality will go to top, means molality inverse. So molality inverse. So Kelvin into molality inverse. We can check, is there any option like that? Only one option is there. Kelvin into molality inverse. Only one option is there. Okay, that's the answer. If you want to check the remaining, how it is coming, sir, that also we can find out. How we can find out? I am writing here. I hope you can see, guys. So here we have delta TB equal to what? Kb into M only. Okay, Kb into M only. So I am writing Kb delta TB means its unit is Kelvin. Its unit is Kelvin. Okay, Kb I am taking Kb, and molality means what? Number of moles of solute divided by number of moles of solute divided by number of moles of solute. So Kb into number of moles divided by what is coming? That is mass of solvent in gram. Okay, mass of solvent in kg will come. in kg will come. So that time kb, number of moles unit is moles. Moles divided by solvent mass is kg. So what it is coming? Mole inverse, mole will be there. So that I am taking, I will write here, you can see. I will write here, you can see, okay. You can see that one, kb equal to, I will write here, delta Kelvin is equal to kb into moles, mole, kilogram inverse will come. Then while I am taking into left hand side means Kelvin mole inverse kilogram will come. So Kelvin kilogram mole inverse. So which option will come? Option A will come. Answer is option A will come. Okay, that's the answer. I hope you guys got it. Okay, I hope you guys got it. Option A is the correct answer. Okay, ready? So if it's so, then we can go to the next question, guys. This is the next question. What's the question? This is the next question. What's the question? In comparison to 0.01 molar solution of glucose, okay, in comparing to 0.01 molar solution of glucose, the depression in freezing point, okay, even though while I'm looking this one, this is somewhat moving, okay, anyhow, no problem, we will do it, guys, okay. So in comparison to 0.01 molar solution of glucose, the depression in freezing point of 0.01, okay, 0.01, depression in freezing point 0.01 molar MgCl2 solution is, that's the question. They are asking you to find out the comparison between depression in freezing point of 0.01 molar glucose with respect to what you have to find out, 0.01 molar MgCl2, okay, ready? 0.01 molar glucose and 0.01 molar MgCl2, regarding their depression freezing point comparison only they are asking, okay, ready? So here, what's the formula? Delta TF equal to, depression freezing point, delta TF equal to I into Kf into M, molality. In both cases, while you are looking, in both cases, the concentration is same. 0.01 molar only. In both cases, the concentration is same. So that means molality is same. And in water only, so that's why Kf also same. Then what only changing? Guys? This I only changing, so I can write delta TF proportional to I. So what's the I value for glucose? I value equal to 1. What's the I value for MgCl2? How MgCl2 will dissociate? MgCl2 will dissociate as Mg2 plus 2Cl minus. Mg2 plus what? 2Cl minus. So what's the I value? I value equal to 3. Meaning what? If here the depression in freezing point is 1, here the depression in freezing point is 3 times 3. I hope you understand. Here the depression in freezing point is 2. Here the depression point is 2 into 3. So that means 3 times the depression freezing point of glucose. Only the freezing point of MgCl2. So what will be the answer, guys? Come on for us. Yes, Sanjay Menon is telling the answer and Faraz is telling the answer, Isham is telling the answer. Yes, great to see that. So option C is the correct answer. What's the correct answer? Option C is the correct answer. What it means? About 3 times. Okay, ready? Okay, so then if it's so, then we can go to the next question, guys. Now we did 16 question. Okay, 16 question. In between I have to tell, we are doing simple as well as somewhat difficult level, everything we are looking. Okay, we are looking this kind of question, easily you can solve it. Once you are reading the question, you have to read it 2 times or 3 times clearly and carefully. Okay, or else mistakes may come. Obviously mistakes may come, twists may become. Okay, so you have to read it carefully. I hope you guys are going to do that one with very efficiently only. I know that. Okay, so if it's so, then we can go to the next question, guys. This is the next question. Yeah, Faraz is putting fire. Yes, Faraz, that energy we need. Okay, so here they are telling, okay, I'm feeling somewhat thirsty. That time only this question is coming. An unripe mango placed in a concentrated salt solution. In salt solution, we are keeping an unripe mango, to prepare pickle. Okay, water is coming out. Okay, shrivels because The shrivels will happen because what's the reason behind that? We know that I am going to take, okay, listen to me very carefully. I am going to take a big jar, okay, big jar of salt solution. In that, what I am going to keep? I am going to keep a mango piece. This is mango, okay. Please forgive me, okay, please forgive me. So this is what I am taking. This is a mango, okay, this is a mango piece, and here it is what? Here it is salt solution, okay, here it is salt solution I am taking. This is a concentrated salt solution, okay, here concentrated salt solution only I am taking. What will happen, guys, now? What will happen now? Tell me, what will happen? Where the water concentration is more? Tell me about where the water concentration is more. You know, inside the mango, the water content is more. Here water is more. What about here? Here the water is inside the mango, water is more. Okay, inside the mango, water is more. Outside, water is less. Water is less. Because here concentrated means solute is maximum. Solute, maximum amount of solute in the solvent. So here water level is less, here water level is more. Always everything will flow from higher to lower only. So from inside that mango inside some water is there, that water will flow outside. So automatically that mango will shrink. That process is called this mango's outer layer, that is a semi-permeable membrane. That idea is called what? That idea is called osmosis. Osmosis, so exosmosis. So that will go out. So what's the answer? It loses water due to osmosis. It loses water due to what? Osmosis. Suppose, so the answer is D. Yes, Faraz Yusuf also telling yes, great. Okay. So similarly, if I am keeping this mango only in water, what will happen? If I am keeping this mango only in water, here water alone, there is no salt, what will happen? Tell me the answer, please. If I am keeping this mango only in water, okay, mango piece only in water, what will happen? What will happen? Yeah, Faraz, correct, Faraz, correct. Okay, it swells up. Yeah. Great. Okay, yes. Mango cells. Yes, Isham, that answer is correct. Okay, ready to see that? Sanjay, where are you? Gujumon, where are you? Yeah. So listen to me carefully. While I'm keeping mango in a fresh water, what will happen? Yeah, swells. Sanjay is telling the answer. Okay. So here water content is more. Outside water content is more. Inside water content is less. So water will flow from outside to inside. Automatically mango will bulge. It will swells. That's the answer. Okay, that's it. So this idea only we are using to make osmosis. Osmosis many places we are using. Okay, so we are using to drying the meat and all, that also osmosis only. Osmosis only we are keeping, because we are while drying the meat and all, we usually used to keep what? The salt solution. Salt solution means automatically. So you listen to me very carefully. Okay, so here it is meat inside meat, if some water is coming, means the bacteria attack or fungus attack will be more and more. Automatically it will undergo decaying. So to avoid that only, what we will do, we will keep it in some salt solution. So what will happen? Concentrated salt solution if I am keeping, means automatically from meat to that salt, that water will come out. Automatically meat will become what? Shrink. So that only the salted meat. So we are drying that meat and all, we are keeping like that only. That's also osmosis. Similarly, in the case of dry fruits and all, we are using it not in salt solution. Instead of that, where we are keeping? In sugar solution we are keeping. That's the idea. Okay, that's the idea. So anyhow, here the answer is 70th question. Answer is what? It loses water due to what? Osmosis. I hope all of you got it. Okay, all of you got the answer. Yes, Faraz. Okay, I can see that. No problem. Okay, you watch it properly. Ready? So this is the next question. What's the question? At a given temperature, osmotic pressure of concentrated solution of a substance is. What's the answer? Tell me. Sanjay Menon, Isham, I'm waiting for your answers. Yes. I hope you can hear me properly. Ready? Right? Yeah. Answer is coming. Great. Yes. Okay. Okay, okay. Listen to me carefully. So, at a given temperature, osmotic pressure of a concentrated solution of a substance. We know it's a simple and humble direct question. What's the idea? Pi is equal to I into CRT. Okay, I into CRT. Then at a given temperature is constant, R is constant. Then what's the idea? Pi is directly proportional to what? IC. So whenever concentration increases, pi increases. Whenever concentration decreases, pi decreases. So concentrated solution, solution at a given temperature, osmotic pressure of a concentrated solution of a substance is higher than that of dilute solution. Because if concentration increases, automatically what will increase? Pi will increase. Yeah, Pinky Ball, correct only? Correct only? Yeah. It's correct only. So that's the answer. What's the answer? A, this one only the answer. Option A is the correct answer. Ready? That's the idea about osmosis. Okay. If it's so, then we can go to the next question. Pyrites is coming. Yes, we can go to the next question. This is the next question. What's the question, guys, here? You have to read it very properly. Okay. Which of the following statement is false? Don't forget that statement. Which of the following statement is false? Okay. Ready? So here they are telling two different solutions of sucrose, same molality prepared in different solvents will have same depression in freezing point. That is wrong. Wrong. Why it is wrong? Because if you are changing the solvent, that depression in freezing point will change, because we know depression in freezing point delta TF equal to I into KF into M. If you are taking same concentration, same substance, even though Kf depends on the nature of solvent. Kf depends on what? Nature of solvent. Okay. Kf will change. Yeah, correct only. Sanjay Menon, correct only. A is false. Okay. This is the false one. Okay. This is the false one. That's the correct answer. What about B? The osmotic pressure of solution is given by the equation pi equal to CRT. No problem. Pi equal to CRT. I is introduced later only, so no problem. That is not an issue. Then what about the next one? Third one. Decreasing order of osmotic pressure for 0.01 molar aqueous solution of barium chloride, potassium chloride, acetic acid and sucrose. In the case of barium chloride, I value equal to what? 3, and this one also 2, this one also 2, this one 1. But KCl is having more value than C3COH, since because of that C3COH is partially only ionizable, not completely. In the case of C3COH, partially only will ionizable, and KCl will ionize completely. So that also correct only. That also correct. So the wrong one is first one. This also correct only. And the last one, fourth option. What's the fourth option? According to Rolle's law, the vapor pressure exerted by a volatile component of a solution is directly proportional to its mole fraction. That is correct. P proportional to what? Mole fraction. That idea is correct. So that also correct. So option 1 is the correct answer. I mean the wrong one, the wrong statement, we have to pick it up. Okay. Yes, KCl is having more value. Yes, Pinky Mole. Yes, that's it. Okay. Pinky Mole is more active. Okay. Great to see Pinky Mole. Okay, ready? Shall we go to the next one? Yes. This is the next one. This is the next question, guys. Again, they are asking the question regarding the Van Hoff factor. Okay. The values of Van Hoff factors for KCl, NaCl, K2SO4 respectively. What is Van Hoff factor in the case of ionic salt? The number of ions produced by the salt. So in the case of KCl, if it dissociate means it will give you what? K plus and Cl minus. So I value how much? 2. Okay. In the case of NaCl will dissociate as what? Na plus and Cl minus. So what's the I value? I value is 2. That's it. What about K2SO4? Already we did about Na2SO4. They are asking about K2SO4. Tell me. Okay, come on. Yes. K2SO4 will give what? 2K plus SO4 2 minus. So that means I value is 3. So what's the option? Tell me the option. Yes, Pinky Mole. 2. Correct. Yes, Mr. Sanjay, for us, Diya. Yes, Diya, nice to see you again. Alina Elizabeth Biju. Yes. Answer is B only. 2, 3. 2, 3. B is the answer. B is the correct answer. The values of Van Hoff factors for KCl, NaCl, K2SO4 respectively. So Sanjay is answering he is answering very correctly. Great to see Sanjay. And for us, yes, B. Faraz is always answering with that fire. That only I need. Okay. Yes, great to see that. Okay, we can go to the next question. The 21st question. I don't know how speedily this time is going on, right? Yeah, pirates also coming. Yes. This is the next question. Okay, this is the next question. 21st question. We have 4 more questions only. So this is the 21st question. Okay. So which of the following statement is false? Out of this, which is false? That's the question. First one, unit of atmospheric pressure and osmotic pressure are same. Same. Why? Because both are pressure. Pressure have same unit, so both are same. That's correct only. That's correct. They are asking about false. You have to remember that idea. You have to find out false. Okay, so that idea is correct only. Unit of atmospheric pressure and osmotic pressure are same only. That's correct. What about the second one? In reverse osmosis, solvent molecules move through a semi-permeable membrane from a region of lower concentration of solute to a region of higher concentration. Listen to me very carefully. Listen to me very carefully. This is the idea I am taking. I am taking here one solvent. Okay, one solution I am taking. Here C1. Its solution is C2. I am taking. In reverse osmosis only they are talking. Okay, reverse osmosis only they are talking. Okay, already answer is coming. Okay, already answer is coming. Already answer is coming. Okay, already answer is coming. No. Sanjay Menon, you have to read the option C. Options they are asking about false only. Sanjay Menon. They're asking about false only. Okay, be careful. That's why only I told there are so many holes are there. There you will go and fall down. Okay, so don't go and fall down. This because this one is so many twists will be there. Okay, you have to be more cautious about it. Okay, so here listen to me very carefully. I will tell you. Okay, this one the concentration of solution 1 is C1 and the concentration of solution is C2. So here I am telling C1 is greater than C2. Okay, the concentration C1 is greater than concentration C2. Then now here I am applying some pressure. Here I am applying some pressure. So the thing is that from where to where normally osmosis will take place. Here concentration is more means water content is less. Water is less. Here water is more. Water is more. That only concentration less means. So normally water will flow from here to here. Concentration less to concentration more only water will flow. But reverse osmosis means that time you are applying a pressure. In the more concentrated region you are applying some pressure. That time from where to where only it will flow. More concentration to low concentration only it will flow. But they are telling membrane from a region of lower concentration of solute to a region of higher concentration. That is wrong. That is wrong. B is the wrong statement. Okay. During reverse osmosis, higher concentration to lower concentration only it will flow. They are talking about water. You have to look about water. That idea you think. Where water is more, where water is less. Water always flow from where to where? Where to where? Higher amount of water to lower amount of water. Abu Ahmad, not D. Okay, don't use D. Okay, don't use D. So B only the answer. That is the wrong one. What about this one? C. I hope you guys got it. Ready? Alina, you got the answer right. Sanjay, Abu, Diya. Nice only right. Set only right. Tell me. Show me the fire and heart. Then only I can move to the next option. Yes, Pinky Mole. Yes. Keep the spirit. Yes, that's it. Yeah, understood. Okay, good. Then what about C? Sanjay Menon told C. The value of molar depression constant depends on nature of solvent. That is of course correct only. Delta TF equal to I into KF into M. This KF will change with the nature of solvent. Solvent changes, that KF value will change. Okay. And the next one, Abu, listen to me very carefully. You told the answer D. Relative lowering of vapor pressure is a dimensionless quantity. That is correct. Because what is relative lowering of vapor pressure? We can write delta P divided by P naught A. Here also pressure, here also pressure. Pressure by pressure, dimensionless. That is dimensionless quantity. So what's the correct answer, guys? The correct answer is B. B is the wrong statement. That idea you have to remember. Don't be fall there. Okay. So that idea you have to remember. Where osmosis will take place? Whenever you are taking high concentration, low concentration means low concentration to high concentration only water will flow. Water only can flow. Solute cannot flow. Okay. Set it. Ready? Okay. Then we can move to the next question. 22nd question, guys. This is the 22nd question. Value of Henry's constant KH increases with increase in temperature, decreases with increase in temperature, remains constant, first increases then decreases. You have to remember, you already learned the Henry's law. Yes, answer is coming. Yes. You already learned the Henry's law. This KH is directly proportional to what? Temperature. When temperature increases, Henry's constant increases. Temperature increases, Henry's constant increases. So what's the answer? Increases with increase in temperature. Don't forget the idea. Ready? Yes. Abu Ahmad is telling the answer. Muhammad Isham is telling C. Remains constant. No, Isham. No. Henry's constant depends on what? Henry's constant depends on what? Henry's constant depends on increase with increase in temperature. Okay, that depends on temperature. Okay, ready, set. Okay, then we can go to the next question, guys. This is the 23rd question. Okay, listen to me carefully. The value of Henry's constant KH is, again they are asking about KH, greater for gases with higher solubility, greater with gases with lower solubility. You learn the idea, P equal to KH into S. So P, pressure increases, solubility increases, P equal to KH into S. You have to remember, when KH value increases, it is found that KH value increases, solubility of that gas will decreases. Okay, when KH value increases, solubility of that gas will decreases. So if solubility increases means its KH value will be smaller. Then what will be the answer? The value of Henry's law constant KH is greater for the gases with a lower solubility. Sometimes they can ask the question like this also. Yes, Diya, correct only. Yes. Alina, that's correct answer. Yes, Isham, that's the correct one. That's the spirit. Okay, keep on going. So they can ask the question like this also. Like what? Like this also. They can give one gas A, another gas B, another gas C, another gas D. Their KH value also they are giving. Okay, Henry's law constant value also they are giving. 3 into 10 raised to minus 2, 5 into 10 raised to minus 7, 8 into 10 raised to minus 4. Okay, and 4 into 10 raised to minus 10. Tell me, out of this gas, which gas will have high solubility? Out of this gas, which gas will have high solubility? I am waiting for your answer. They given A, B, C, D, 4 gases they given, and their KH value also they given. Out of this gas, which gas will have high solubility? Tell me. I am waiting for your answer. High solubility. Sanjay Menon, look at the option please carefully. Look the option carefully. Yes, Pirates is telling the answer. Sanjay Menon is telling the answer. Zebi is telling the answer. Yes, Alina. Yes, correct. Diya. Gujumon. Yes. Great to see that. What's the idea? KH value increases, solubility decreases. I am asking about solubility is more for the one with low KH value. Which one is having low KH value here? It is 10 raised to minus 2, 10 raised to minus 7, 10 raised to minus 4, 10 raised to minus 10. D is the correct answer. How many of you told the answer D? That's it. Yeah. So many are told the answer D. Yes. Okay. Great to see that. Then we can go to the next question, guys. Are you ready? Guys? Shall we go to the next question? 24th one. Sanjay. Yes, we can go to the next question. We can move to the next question. This is the next question, guys. Yes, if two liquids A and B forming minimum boiling azeotrope at some specific composition, then, okay, if two liquids A and B form minimum boiling azeotrope. Okay, listen to me very carefully. Minimum boiling azeotrope. Okay, minimum boiling azeotrope. What do you mean by minimum boiling azeotrope? Minimum boiling azeotrope only they are talking. Minimum boiling azeotrope means positive deviation. They will show positive deviation. Maximum boiling azeotrope means negative deviation. This is about positive deviation. In the case of positive deviation, what's the idea? FAA and FBB are greater than FAB. Solute is not like to be along with the solvent. Okay, so that's why solvent interaction, solute interactions are more. than that of solvent-solute interaction, in solution interaction. So that's why, that's the idea. So we can check the option. What about the option? AB interactions are stronger than those of AA or BB. That is wrong. That is wrong, because AB interactions are weaker only. What about the next one? Vapor pressure of solution increases because more number of molecules of A and B can escape from the solution. That also correct statement. Vapor pressure of solution increases. Yes, of course. Why? Because AA interaction as well as BB interaction is more, meaning A and B will escape easily. So that is correct one. Okay, that's the correct statement. Not only that one more correct option is there. That is the correct one. And the second one, vapor pressure of solution decreases because less number of molecules, only one of the liquids escape. That is wrong, because both A and B together they will go to top. Okay, both A and B, because more number of molecules of liquid A and B can escape from the solution together. Okay, together. So then again, AB interactions are weaker than those of AA and BB. So option B as well as option D, both are correct only. Both are correct only. Both options are correct. Okay, B and D, both are correct. I hope you guys got it. Both B and D are correct. Not only D, both B and D are correct. Okay, here both B and D are correct. I hope you guys got it. Ready? If it's so, then we can move to the last question, guys. This is the last question. What about the last question? We have three aqueous solutions, NaCl labeled as A, B, C. I am having three aqueous solutions. This also NaCl, this is also NaCl, this is also NaCl. Okay, NaCl solution only, labeled as A, B, C. And their concentration is same. This concentration is 0.1 molar. Its concentration, not same, its concentration is 0.01 molar. Its concentration is what? 0.001 molar. Okay, 0.001 molar. Their concentration is different. They are asking about the Van Hoff factor. You must have to remember, Van Hoff factor does not depend on the concentration. It depends only on your solute. It depends only on your solute, which solute it is, what's the kind of solute it is. So here also NaCl, here also NaCl, here also NaCl. That NaCl will dissociate into what? Na plus and Cl minus. Here also Na plus and Cl minus. Here also Na plus and Cl minus. So Van Hoff factor of A is Ia, Van Hoff factor of B is Ib, Van Hoff factor of C is Ic. All will be equal. Option C is the correct answer. That's it, guys. I hope you guys enjoyed this session. You guys participated with that much energy. That is, I'm so much grateful. Okay, so work hard, and you have to read the question very carefully. That again I am telling, because you people are losing the marks in the assertion, reason as well as MCQ only. You have to do it. We will have to get it. We have to get the full mark in chemistry, physics and all. Okay, so we will meet again. Up to that, thank you.